The next lesson is on the relationship between horsepower, torque, and speed. And work is the force of an object causing it to move. In this illustration, the work the horse did was moving 550 pounds, and it moved at 1 foot in 1 second. A horsepower is the rate at which work is done. It takes 1 mechanical horsepower to move 550 pounds, 1 foot in 1 second. So the horse exerted 1 horsepower doing this work. But if 1 horsepower moves 550 pounds, 1 foot in 1 second, that's equivalent to 33,000 pounds, 1 foot in 1 minute. A motor delivers a rotating force, and a rotating force is known as torque. So torque must be considered when we talk about motor horsepower. And based on the understanding that horsepower can do 33,000 pounds of work in 1 minute, and incorporating torque into the equation, the following equation is derived. Horsepower equals torque times RPM divided by 5252. And from the equation, we see the torque and RPM are proportional to horsepower. So with same torque, as RPM increases, so does horsepower requirement. More horsepower is required to produce the same torque at more speed. And with the same torque as RPM decreases, so does horsepower demand. Less horsepower is required to produce the same torque at less speed. With the same RPMs, as torque increases, so does horsepower. Base speed corresponds to the speed the motor will run at full armature voltage, full armature current, and full field flux. A DC motor can operate at rated torque at any speed up to that base speed. This is often referred to as the constant torque region. Now, the actual torque produced, however, is determined by the demand of the load. Some applications require the motor to operate above base speed, but armature voltage isn't rated. What do? If the field were to be reduced once the motor reaches base speed, the field flux would decrease, causing the counter EMF to decrease. And this would speed the motor up due to the larger voltage difference between applied voltage and counter EMF. This strategy works, and it's applied in many applications. The nameplate will provide the minimum current for full field weakening, and that field should not be set lower than this current level. A DC motor can operate at rated torque from 0 to base speed. This is often referred to as the constant torque region. At rated torque, as speed increases, horsepower increases. A DC motor can operate at rated horsepower from base speed to max speed. This is often referred to as the constant horsepower region. As field is weakened, the speed increases. However, the torque rating decreases. Torque demand must decrease when operating in the constant horsepower region.